Okay, we are going to start our data analysis test review. Number 1, the table shows the times Michael cycled and the distances he cycled while training for a race. Create a scatter plot to represent the relationship between y, the distance Michael cycled, and x, the amount of time to travel the distance. So we have a table that gives us all of our data points, and we're going to go ahead and plot it in the graph. So in 1 hour, he traveled 14 minutes, so we're going to look at where the time was 1, which is right here, and where the distance was 14, which is going to be between 12 and 15, a little bit under 15. So we're just kind of making some estimates here. I'm going to zoom in. The second one is 2 hours, and he cycled 12 miles. So 2 and 12. And then for 0.5 hours, he cycled 4 miles. So that's going to be in between 0 and 1. And then that's 4, so a little bit more than 3. Let's see what I can get right there. Another time when he cycled, 1 hour, he traveled 7. That's above 6. 1.25 hours and 8 miles, so a little bit more than 1, and he traveled 8. 2 hours was 11.75, so it'll be like right here. 5 hours is 22 miles, 5, 22. I think I skipped one. 2 is 11.75. 2.25 is 13. So that'll be like right here. There we go. 4 hours is 21. So like right here. 3.5 is 18.6. 6 hours is 23. And 6.25 is 25. So describe the scatter plot association. This one looks like as the time is increasing, the distance is increasing, it's going up. So I would say that this is a positive. Is the scatter plot linear or nonlinear? For the most part, it's going in a straight line. There's no dramatic curves or waves in it at any time. So we're going to say it's linear. So as the number of hours increases, right, because we're going in this direction, so that's increasing. So increases. The distance, if I'm looking at that Michael cycled, also increases, right? The more hours he cycles, the farther distance he's going to go. Label the graph as linear or nonlinear. Remember, for it to be linear, it's generally a straight line. For it to be nonlinear, there's an obvious curve or wave in it. So this one is generally straight, so we're going to say that this is linear. This one is also generally straight. It is also linear. This one, however, has a curve to it, so we're going to say that this one is nonlinear. This one, again, has a curve to it, so we're going to say that this is nonlinear. And this one is generally straight, so we're going to say that this one is linear. Problem number 3, Elijah plays soccer and is also in advanced math. The scatter plot shows the number of hours he spent for each of the last 10 weeks practicing soccer and studying for math. Which is the correct conclusion based on the scatter plot? So let's go ahead and look at the graph. So one thing that I noticed right away is that it is negative. Okay. As the hours practicing soccer increase, the hours studying math decreases. Okay. So as soccer increases, studying math decreases. So let's see if there's an answer choice that matches that. As the hours spent practicing soccer increases, the hours spent studying math increases. No. The more time he spends practicing soccer, the less hours he spends on math looking at the graph. So that's not right. As the hours spent practicing soccer decreases, the hours spent studying math decreases. Well, if we were going in this direction, okay, for example, 6 hours of soccer, he studies math 1. For 1 hour of playing soccer, he studies math for more than 5. So that's not true. They're not both decreasing. As the hours spent practicing soccer increases, the hours spent studying math decreases. This one could be it. There is no association between the hours spent practicing soccer and the hours spent studying math. It's not scattered enough for us to say that. We already talked about that this was negative, so there is an association. So my answer has to be H. Number 4. The graph below shows the number of pages and the approximate number of words in several books, which conclusion is supported by the scatter plot. So before we even look at our answer choices, let's look at it. So it looks like if it's generally increasing, so it's positive. We have one random outlier, but that's okay. The rest of the data points look like if they are positive. So as the pages increase, the number of words she's read also increases, okay? So we're going to look for an answer choice that describes that. As the pages of the books increases, the total number of words decrease. No, the more pages she reads, the more words she's read. As the pages in the book decrease, the total number of words decrease. It could be this, right? The less pages there are, the less number of words there are. That's true, right? As the pages in the book increase, the total number of words increase. This is also true, right? So it's just going forwards and backwards, but they're both going in the same direction. Decrease and decrease, increase and increase. Both of those represent a positive relationship, which we've already talked about, that it was increasing, so it was positive. So my answer choice, whoops, didn't mean to circle that. This should have been an X, sorry about that. A is not true. Okay, so my answer choice is D. Both B and C are true. Make sure I didn't skip one. Whoops. Number 5. The number of books read was recorded for 8 people. The scatter plot shows the age and the number of books read in the last year. Which statement is best supported by the scatter plot? So let's look at it before we even look at our answer choices. It generally looks like if it's a negative, right, line. As the age increases, the number of books read in a year decreases. So let's see. There is a nonlinear association between the number of books read last year. There is a negative association between the number of books read last year. That's what we thought it was. There is no apparent association. No, it's not scattered enough. And there's a positive linear association between the age and the number. We know it's not positive because as age increases, books decrease. So that would be negative. So generally, it looks like if it's a straight line. So I'm going to go with A. Oh, I'm sorry, with B. I'm going to cross out A and go with B because it looks linear. The scatter plot shows the temperature and the amount of ice cream sold on 8 different days last month. Which of the following best describes the correlation for the data? So it's generally a straight line. And it looks like as the sales in dollars increase, the temperature also increases. So we know that that would be a positive relationship, so I can cross out A and D. It generally looks like if it's a straight line, so this should be linear. I mean, you could pick B or C. I'm pretty sure one was supposed to say nonlinear, but there's a typo there. So we're going to pick positive linear. Number 7. The scatter plot shows the average selling price of cars and the age of cars. Draw a trend line and approximate the data for what selling price should an owner of a 9-year-old car expect. So we are going to be using our patty paper for this. So we're going to fold it, trace the crease, and then open it up and trace the crease so we have a nice straight line. We can now put it on top of our data. Now I don't have patty paper to use on my iPad, but we are just going to use a line, and I'll be able to rotate this line and turn it as I need it. Whoops. There we go. and I want it to try to be in the middle of the data as much as possible. So on your patty paper, you'll be able to turn it. I think that's pretty good. I'm crossing a couple of points. It's in the middle, more or less. There we go. That's pretty good. Anything close to this would be a good choice. So now that we have our trend line drawn, we're going to look at what it asked us for. It asked for a 9-year-old car. So we're going to be looking at where the age of the car is 9, which is right here. We're going to go up to our trend line. We said it was like right here. So it's between 2 and 4. So we're going to say about 3,000, a little bit closer to the 4, so like $3,000 to $4,000 because it's in thousands of dollars. So about 3,000 to about $4,000 would be a good guess. So we're going to pick whichever answer choice is closest to that on our STAR test or on our test tomorrow. Below is a scatter plot that shows the relationship between the number of words typed per minute and the number of letters typed incorrectly. Draw a trend line and approximate the data for the number of letters missed if you were typing 70 words per minute. So we're going to go ahead and use our same patty paper. And we're going to draw a trend line. I know this isn't a great one, so I'm going to move it around. That's why we have it on our patty paper. So we'll be able to move it around. Let's see. I think there's pretty good. Now remember, your scatter plot doesn't have to cross your trend line doesn't have to cross the origin. All you care about is making sure it's in the middle of your data. So as you can see here, it doesn't cross the origin, which is perfectly fine. So we're looking for the number of letters missed if we were typing 70 words per minute. So we're looking at the words per minute. This is number of incorrect words, so not that axis, words per minute. Yep, that's what I want, 70. I'm going to go up to 70. It's about right there. Go over. Whoops. Go over. And I get about 22. About 22 incorrect words. So I'm going to pick the answer choice that's about 22. Number 9. The scatter plot shows the number of years of experience of 8 different wedding photographers and the number of weddings they photographed over the last year. Based on the scatter plot, what would the best prediction of the number of weddings that a photographer with 7 years of experience would photograph in a year? So we're going to go ahead and draw our trend line. We can use our patty paper. And we want to make sure that we go all the way across, right? Extend past the graph. Make sure that we're going all the way from one end to the other end, so that way we have a trend line over the whole thing, no matter which question they ask us. But this one is asking us about 7 years of experience. So we're looking at the years of experience, which is the x-axis, 7 right here. We're going to go ahead and go up. Go over, I get about 60. So about 60 weddings. The closest one to that is B, 57. Number 10, Isaac collected data from several of his friends about the number of hours they spent sleeping and the number of hours they spent playing video games on Saturday. He recorded the data in the scatter plot. Based on the scatter plot, what is the best prediction of the number of hours one of Isaac's friends spends sleeping when the friend spends 1 hour playing video games? So we're going to go ahead and draw our trend line. There we go. This looks pretty good, pretty much in the middle. Make sure that you extend it from one end of the graph all the way to the other. So we're looking at 1 hour of playing video games. So 1 hour of playing video games. So this is hours of sleep. So we're not looking at the x-axis this time. This time we're looking at the y-axis, where the y is 1 hour of playing video games. About here we go over. So it's closest to 9. So we're going to say about 9 hours. Now let's talk about mean absolute deviation. Mean absolute deviation is the average distance of each data point from the average. So step 1, we're going to find the mean or the average of the data, which we do by adding up all the points and dividing by however many numbers we added. Step 2 is find the distance between each data point and the average. Step 3 is going to be find the mean or the average of the distances. Step 4 is going to be state what it means, which is each data point is an average of blank away from the average. So question 11. The table shows the number of customers Groceries Galore has over the past 5 days. What is the mean absolute deviation of the numbers in this list? So step number 1 is going to be to add all of these together. We can do that in our calculator. 43 plus 29 plus 76 plus 102 plus 35. And I get 285, but that's not my answer. I still have to divide by however many numbers there are. So I added 1, 2, 3, 4, 5. So divide by 5, and I get 57. So step number 1, my mean is 57. Erase this. Okay, so I have my mean. Step number 2 is to find the distance between each data point and the average. So I want to know how far away is 57 from 43 and from all the other numbers. So for me to figure out how far away 57 is from 43, we're going to go ahead and subtract those in our calculator. 57 minus 43 is 14. So I'm going to write that under the 43. 57 and 29, so we're going to do 57 minus 29. We get 28. 57 and 76, so we're going to do 76 minus 57. We get 19. 102 minus 57, we get 45. And 35 minus 57, we get 22. So remember that these are all positive. Whether you get a positive or negative in your calculator, you're just going to write the absolute value of it, so they're all going to be positive. So step number 2 is going to be to add these all up, all of my new numbers, and then divide them by however many numbers I have. So 14 plus 28 plus 19 plus 45 plus 22. I get 128, but that's not my answer. I still have to divide by however many numbers I added. 1, 2, 3, 4, 5. So divide by 5. Control Enter, and we get 25.6. So my mean absolute deviation is 25.6. So this means that each data point is an average of, for this problem, 25.6 away from the average. Now let's do our last problem, number 12. The number below represents the amount of time in minutes that it took Jalissa to get to work each day last week. What is the mean absolute deviation for these numbers? So step number 1 is going to be for me to find my mean. So I'm going to add all these numbers up and divide however many numbers I added. So 21 plus 26 plus 47 plus 44 plus 22. And there were 5 numbers, so divided by 5. So my mean is 32. So I want to figure out how far away each of these numbers is from 32. So 32 minus 21, and I get 11. 26 minus 32, or 32 minus 26. And we're going to write the positive number. We get 6. 47 and 32, so 47 minus 32. We get 15. 44 minus 32, we get 12. And 32 minus 22, we get 10. My next step to find my mean absolute deviation is to add these together. 11 plus 6 plus 15 plus 12 plus 10, and I get 54. Then we're going to divide by however many numbers we have. So divided by 1, 2, 3, 4, 5. And we get step number 2, my mean absolute deviation, which is 10.8. So this means that each data point is an average of 10.8 away from the average for this one.